All right. Welcome back to Context Ops. Hello, Casey. How are you?
I'm excellent. Pleased to be here.
Thank you so much for taking the time for doing this, Casey. Really appreciate this. Right now, for the audience context, Casey Hart is an actual ontologist. Can you guys
We do
believe that?
exist. Yeah.
For the longest time, this title was something that I think Palantir had a copyright on or something like that. But ontologists actually exist. Casey is a real one. And today we will dive deeper into figuring out what actually is an ontology, apart from everything that you have seen on LinkedIn and Twitter and Reddit and YouTube and so on, right? But before we get into this, Casey, right, how does somebody with a PhD in philosophy ends up working on what some of us call as foundation for generative AI? Like, how does that happen?
Yeah. I mean, the way I got in there had nothing to do with generative AI. It was a little bit pre-generative AI. But the path to becoming an ontologist is wide and varied. It's something I talk about on my YouTube channel and with other academic philosophers who are maybe thinking about their way out. The way my particular journey happened was I was getting my PhD in philosophy, which means you want to teach it and be a professor almost certainly, unless you're like getting into law or something. But then you probably just get your MA and then go there. And philosophers go to philjobs.com to find their job. And so I went there, and you apply to every area of AOS or AOC that you can squint and pretend like you qualify for. And one of those qualifications was for this random company called Cycorp that put a posting up, and I was like, that's not academic, but whatever. I'm applying for all of that stuff, and got an interview at Cycorp with Doug Lenat and got offered a position. It was between that and some postdocs, and I was like, well, this is a job that I'll view as a postdoc that pays me a little more money and that we can sort of settle down. My wife and I had a 2-year-old at the time and a negative 1 month old at the time. We're like, we don't want to be traveling a bunch and like immediately reapplying for new academic postings. And so I found myself as an ontologist, thought I would be there for, a year or two. And then like my deep and detailed plan was I'll reach out to some liberal arts applications, right? And I can tell those business deans that not only can I teach philosophy, but I know how to get a real paycheck using it, and that'll make me irresistible. And before that happened, I was like, wait, this ontology thing is super fun. I get to it scratches a lot of the philosophical itches. I get to do some, learn new things, formalize stuff, think carefully about logic and inferences. And so I just found myself getting farther into the career. Yeah.
That's such a believable story.
Well, good, because I made it up. So I'm glad you believed it. I was just trying out new things every time.
No, it all adds up, right? A philosophy PhD looking for way out of postdoc. Yeah, I mean, it makes sense, right?
But I will say, like, it's not, from that, it's like, oh, it's a weird journey or whatever. And there, like, I've met jazz musicians who got into ontology, all these sorts of things. I would say philosophy actually makes a lot of sense as a way in, right? So when you're ontology, a bunch of ways to conceive of it, but one of them is like, it's the if you take that like left brain, right brain, Kahneman and Tversky view of psychology, where we have like this thinking fast and we're just sort of like gut reaction, that's kind of like machine learning-ish. And then you've got the thinking slow, like logical and more methodical approach. That's where good old-fashioned AI, that's where ontology sits, is building like a model that can ground those sorts of reasonings. And that's the kind of stuff that I think philosophers are pretty good at. Like, let's stop, let's reflect on what our assumptions are, let's formalize those assumptions, let's see how they fit into arguments that would generate the sorts of inferences and conclusions that we want, right? That kind of, combination of like carefulness and a little bit of like creativity and mathematical formulations all sort of suits itself pretty nicely, I think, to this field.
I agree, because Josh Hare himself has a strong philosophy background. One of the ways we describe
that's not true. Not philosophy, but maths, and it has overlaps, but it's not philosophy. Yeah.
I stand corrected. I thought it was potato, but okay, maths. Sure.
Well, it's like, if you were a doctor and engineering student, they would be like, maths is about calculations. And that's not what we studied. I mean, yeah, we had some calculations, but we had things like, why is 0 plus 0 0? And that's a stupid question. These are the stupid questions that we had to prove. And that was what maths was about. So in that sense, yeah, it has some overlaps. I think it used to be taught together and now it's different for good reason. But yeah, I mean, I'm not a philosopher, but I like math. I don't regret that journey. That was my
Yeah.
fun time.
All right, cool. So you see, one question which you obviously have been building ontologies before transformers became popular and before GPT 3.5 and so on, right? But when these models sort of came around and they became like extremely important and critical to a lot of people, right? What was that point when you realized that nah, this ain't it? Like, when did you realize that? Like, no, this still needs a lot of exactly what he said, right? It needs a system 2. This is only a system 1,
Yeah,
right?
yeah.
Yeah.
Some of it, I was never that sold on it being everything, right? Like when you say this ain't it, which is a sentiment I agree with, I don't want to overstate it and be like, oh, I think LLMs, generative AI are worthless tools. They don't do anything for us. They're super cool. They do lots of awesome things. A lot of the discoveries and sort of the types of answers that you can get from LLMs are like surprising, and understanding why we get those kinds of results is important and good, both in computer science and psychology and all sorts of things. So there you go. Now I've said the positive things. Now I can go back to the negative things. Why would I be negative about it? One is a contrarian spirit that I have, perhaps, but just for the longest time, LLMs still fit broadly under the machine learning, umbrella of things, right? And so from, as someone who learned a lot about artificial intelligence under Doug Lenat, like he, for the longest time, was talking about left brain, right brain sort of stuff. So in that sense, there was nothing new here, right? But the other piece for me is just when you're thinking about like fundamentally what is going on. We've got a bunch of training data. We are building up a model that compresses the information in that training data, right? And this training data is a bunch of depends on the model that you're looking at, but like text from the internet. And there's a bunch of like that text correlates with a bunch of important knowledge. That's true, right? But as we're compressing that down, it's just not possible to think that that's got like a total understanding of what the world is like, right? And it's a little bit of a pejorative to say that all LLMs are doing is just guessing the next word. But there's something importantly true about like that is the kind of thing that's going on. It turns out that that's a really powerful technique and that you can look at bigger context and those sorts of things. But fundamentally, it's just trying to be a pattern predictor about the kind of thing that would make a sensible, like the kind of sentence you would see in the training data. And of course, that's not inference. That's not knowing facts about the world and then reciting those facts to you. So you're going to end up with these hallucinations, other sorts of things. I hate calling them hallucinations, but I think the term is stuck.
Yeah. We also, I think we internally use the word generation more than hallucination, right? That it's generating stuff, just that it aligns with your point of view at times, and it's at that time it's not a hallucination. And when it does not align with your point of view, it's a hallucination, or something of that sort, right? It triggers that reaction from people.
The thing that bothers me about the hallucination is like I almost just want to call it a bug, right? Like we have a text generator and it's generating bad text. That's a bug, right? But when we make it a hallucination, not only do we sort of give it an excuse or something, right? We have like built it up to be more like psychologically sophisticated than it is, right? Like we don't do that for other sorts of like, if you cut the brake lines to my car or something and like I'd run into the garage instead of coming to a stop, and the manufacturer was said something like, oh, the car made an educated decision that stopping was unwise at that point. I'd be like, no, that like car wasn't thinking, right? Like you just gave me a bad product. And yet when LLMs screw things up, we like make them seem like they're even smarter. Oh, this is so sophisticated that it's messing up. Like that's not right.
Yeah, no, I totally agree. The other version of this, which also gets discussed, is when you call it a bug, it also means you can fix it or it's fixable, right? But the reality is, you try the same request, and you might actually get a better output, right? Or the other way of looking at it is, which is if it makes it sound like it has some disease and that you can fix it, or there's a healthier version of this LLM instance running somewhere out there. So let's go chase that healthy version. right? Let's get the LLM with less sugar or less carbs or whatever that is, right? And that reality that's not reality, right? Every model, every LLM will have the same core traits, which is generate when you can, right?
Good.
So yeah.
Yeah,
No,
it's doing.
thanks.
I see that. I appreciate that. So instead of calling it a bug, which suggests that we remedy it, and maybe there are ways to change the model or the software that sits on top of the model to make more generally appealing outputs. But fundamentally, the thing wasn't doing anything wrong. It was performing exactly as intended, which was making text in accordance with the vector spaces and the various rules and weights and random number generators that you assign to them. Yeah, so it was doing what they asked it to do. It just turns out that we don't like all the things that we asked it to do.
That's it. That's
Yeah.
that's pretty much it. All right. So see, going back to your first stint as an ontologist, right, where that work was pretty much in their own proprietary representation language, which I think you've mentioned is to be very different from the OWL and the RDF world, where most of the conversation today is happening in.
Yeah.
Right. How was that experience in terms of learning, which is not today happening, let's say, in the OWL and RDF world? Or what is it that you can carry from there over here? Yeah.
Yeah, great. Coming from philosophy, right? I did some formal stuff, getting back to talking about Josh and math and philosophy and how these things tied together. Like I did Bayesian epistemology, I did some, various logics. So I was used to some, symbolism and formalization and computation, but I was not a programmer by any stretch. And when I got to Cycorp and they have their language, which was Cyc-L, so it's CYC as in encyclopedia, that's Cycorp. The company sounds so evil, right? Like it would fit in the Skynet or whatever that you're doing in the Terminator. But Cyc-L is like a Lisp variant out there. So I didn't have any basis to say like, oh, is this more or less complicated than it ought to be? I was just learning the representation, and it didn't seem way harder than any of the like quantified modal logics that I had been dealing with. So it was fine, and had some really nice programmers there who took me under their wing. And thanks to Emma and Andrew for putting up with my stupid questions about how to write Lisp functions. And so I learned that stuff. The big differentiator between, and you can think of OWL RDF has some like short Lispy kinds of constructions too. So those are not all that different. The biggest difference was at Psych, they wanted like a very robust expressive language. And so you could have predicates or properties that related as many objects as you liked, right? So in OWL RDF, you have basically two place relations. You're making a graph, right? So our knowledge graph has nodes connected by edges, right? So I can say like Casey ate pizza. So Casey and pizza are nodes in our graph, and 8 is a predicate or a property or an edge that connects those two types of nodes. But of course, we can have really complicated properties, right? Like we could have, Vivek and Casey and Josh do a podcast together. And so I could make the do a podcast together, or I could make participate in event type podcast participant, and I can have a list of as many objects as I want. So you can make those relationships crazy, right? And now you're not thinking about a 2-dimensional or maybe even 3-dimensional graph. You're in like n-dimensional space, and it would look really crazy if you were trying to represent it there. But basically, I really liked that as a basis for saying, take any simple, like, or as complicated a sentence as you want, and you should be able to represent that in your ontology. Right? All the facts about the world, we should be able to put that into our ontology. And Cycorp in particular had the mandate of, we want to get common sense reasoning into the knowledge base. And that means we want to represent facts in as general a way as possible. And so instead of representing some fact about, I don't know, like my tennis racket fits inside my tennis bag, right? I want to say, well, there's a general principle here that is smaller objects can fit inside larger objects or something like that. Or larger objects can't fit inside objects that are smaller than them. And this is going to be used for like whether my tennis racket can fit into my backpack as opposed to my tennis bag, or whether the horse can fit into my Pathfinder rather than, fit into the horse trailer, or whatever you like. So you have this like stating general rules about reality and thinking, being not constrained and trying to fit that into smaller constructions was actually really helpful. When I went to OWL RDF, that was, partly at the time, it was like, oh, wait, I think I like ontology. I'm not going to just leave and go back to academia or something like that. So let's see how everybody else are doing these things. And at Psych, we always had this insult that we levied at people who are doing OWL and RDF, saying like, they only get to say things in like 3-word sentences. But how ridiculous is that? Like, the world's more complicated than something you could just say in 3-word sentences. And I got good at giving that line in sales pitches, but I was like, I don't know if that's a good approximation of what's going on in OWL RDF or not. And so then I went and played around with it myself and learned how to do stuff. And in some way, it's way simpler. So it's easier for me to express stuff. There are times when I'm upset that like, oh, I wanted to say this like more fine-grained things, and now I have to find like tricks to avoid saying the more complicated thing and then, compressing it down. But it's not too bad. And there are constructions, like you have list objects in RDF. So if you really want, you can sort of secretly make predicates as long as you'd like them, because you can just make subject and predicate, and then in the object, you can just put a list, and that list can be as long as you like. That's terrible practice. Don't do it most of the time. But sometimes you try and shove a more complex data structure in there for special cases.
I'm guessing RDF star is also making things easier.
I don't think so. So what RDF star, right, or spec, what is it? 3.2? I forget the 1.2. Yeah. So for those listening who may or may not know what that is, say that you want to represent something like the classic example is a marriage, right? So Josh and I get married and then we get divorced. It was a tough first stint, but then we decided to give it a go again, and we get remarried. Well, in RDF and OWL, if you say Casey married to Josh, and then later I say Casey married to Josh, those are the same triple, and so they just sort of get compressed. And this is one of the things that people say in favor of like labeled property graphs, which allow you to put special additional data on top of the edges, right? But the way that you can solve that before in OWL RDF is instead of saying Casey married to Josh, I can say there's marriage 001 that has participants Casey and Josh, right? And then I can put dates on that. And then I have marriage 002 that has Casey and Josh as participants, and that has different date constructions. So instead of just having two edges, I want to distinguish the edges, I reify the event, is what we say. So what RDF 1.2, RDF star does is it allows you to express the sentences as triples themselves. So I can say Casey married to Josh is my sentence, and I can say when that sentence was true. And then I can say that sentence again, this RDF statement, and then say that was true at different times. But if you could reify the events, right, marriage 1 and marriage 2, or you could take the propositions, the RDF statements, and they turn out to be exactly isomorphic structures. So RDF star, RDF 1.2, I don't think actually, it doesn't give you any more expressivity. I was talking to Ora Lasilla about this at the recent Knowledge Graph conference, and he's a semantic web Mount Rushmore guy, just awesome dude to talk to. And he is on that W3C committee for making the RDF 1.2 spec. And I feel confident in my assertion because he feels about the same way, where it's like, yeah, it's isomorphic. You're getting the same structures. One nice thing about RDF 1.2 is it's another place where you can store information and metadata. And so if you wanted to just use those like RDF 1.2 statements to say like who made the assertion or how confident we are in the assertion or something like that, these sort of like, they're not strictly speaking models about the world, but they're meta statements about the data model. That's a good place to hang those things. So maybe it allows me to separate out some of those interests.
Yeah. I was talking more about the expressivity of the language itself, like to be able to express more and less, which is, I think, what you were talking about in Psych.
Yeah, but then like because you can reify the events and you could reify the statements if you wanted to in other ways already.
Yeah, you could
so
do it.
I just don't think it helped you, and it didn't give me any new colors or paintbrushes to paint with.
So what would you like to see in like RDF? Or
yeah, I mean, I would like some more standard. Mostly, I think it's on the Sparkle side of things. Like, I'd like to have a little bit more control over how queries are run or sequenced in a standard way. In some ways, I'm not missing all that much because you can just build your own wrappers around things. And like, that's what I've done with my various clients and my personal ontology stuff. But I would love And there are some companies who have tried this before, haven't always been super effective with it. But to say like bind this variable first, right? Here's a long query. Go get those ones first because there's only going to be 5 of them, and that's going to be easy. And instead, when I go from triple store to triple store, I have to learn like, is it random how they're picking out these bindings, or do they just try and bind the highest up variables or the deepest nested variables first? And like if that stuff was super clear, that would make the Sparkle querying easier and better. And I think improving the query stuff is more important than anything else because that's what's going to be powering your APIs and applications and stuff. So if I can make that fast and accurate and standard, that would be awesome.
So more like graph, algorithms walking the graph more easily, being more expressive, giving you more options basically.
Yeah.
In the query language itself.
Yeah. I mean, for some of the other stuff, right? Like as much as I like the additional expressivity that we got at Cyc, and that's super cool, that comes with slowness, right? The reason that OWL
what happened to Cyc? I think it was like one of those big things, right? Like up there with, was it DBpedia or something like that? Like or schema.org.
Yeah.
All of these movements that were happening. Is it still around? Is it merged into something? What happened there?
Is, I think, in a coma would be the right way to metaphorically describe where Cycorp is at. I don't know the exact state of it right now. I don't think that from the outside, without any inside information, I've been away from there for a while. It felt like things ran out of steam, general economic concerns and other stuff. And with Doug's passing, that probably didn't help things for, preserving some clients and acquiring some new ones. And it looked like they were hoping to be acquired or something, and that stuff wouldn't be as sustainable. That's my sense of things. Yeah. There's, they had some issues over time, but also they were tremendously successful in other ways to just be doing that since the mid-80s.
It was quite popular, I think, till very recently.
Yeah.
In fact.
Yeah. And you'll find like Cycorp is an incredibly polarizing place. I think you'll find lots of people that are like, if we invested more or did a little bit better, like the singularity would be here by now, or like Cyc is the key to it. And then you'll have other people who will tell you that it was, borderline criminal and abusive enterprise and wasted a bunch of things. So like the truth is always somewhere in between, right? Like they did some awesome and cool stuff and they gave me a start. I'm forever grateful for that. And there are lots of amazing things that I wish they could have done a little bit better job at getting out there for long-term business aims and stuff. But it was a fun ride.
I guess that was AGI back then.
Yeah. Well, I mean, some of the stuff, like when you want to talk about, there were competing camps, right? Since the origins of AG or AI discussions, like in the 50s and 60s, where you're building computers to model and understand the way that human minds work. And some folks were on the good old fashioned AI expert system side of things and say, I don't care what you do, logical reasoning and computation is what's going on in the brain. And when I say that penguins are birds, but they can't fly, but I also say that all penguins can fly or all birds can fly, I am doing exception-based reasoning. I have these assertions. And like Cyc was a model that was trying to get all of those core facts and do exception reasoning and stuff like that. And then in the other camps, right, you have people that are like, nah, it's machine learning is going to get there eventually. And we just need to see when we have enough computing power. And there was like this race between the expert system sides of like, we just need to build up a big enough repository of digital facts that we can leverage to get the kind of reasoning that humans are doing. The folks are like, we just need to get the processing power and the training data sets to get these kinds of things. Yeah. And the debate is still out, right? Some people are super, we talked about whether LLMs are it or not. I say no in some respects, right? But there are some people out there like, you guys were dumb because you didn't think LLMs could do as much as they could do now. Like if we just get some more processing power and some more training data, then it'll tell us that, penguins can't fly, but all birds can fly for exactly the right reasons too. So yeah, but Cycorp was hot.
But where do you sit? Like, are you more symbolic, more neural? Like, where are you?
I think that the right response is going to be some sort of hybrid response. It depends on what question we're asking. One question is how do these things work? Tapping my head while we're on a podcast, right? Like, how does the human mind and human brain work? And is it the sort of thing that has parts that are irreducibly computational versus more like machine learning sorts of things. I don't know. Like, I don't know enough about psychology to say that sort of thing. I think that's interesting. But then there's the other question about like, what are going to be the best AI answers, right? And for me, I think that there's going to be some sort of hybrid solution as the right one. Like machine learning stuff is like obviously really good and really useful, but it's very error prone and it's really computationally expensive and it's not very transparent. So when we're leveraging a tool like that, that's going to be really valuable in certain cases where we have the right sorts of data, or we want to generate some new insights by taking advantage of computational power. But then there are lots of times when we have to be able to trust the output. And I'm not going to trust the output of something that was like, I ran 6 billion computations and generated these vectors, and I give you this answer. Just take the chemotherapy. No, thank you. So the right answer for me is going to have to use a bunch of data, machine learning algorithm sorts of things, but it's going to have a ground world model and sets of reasons and inferential steps to explain to me why I should be compelled by the output of the machine.
Right. Awesome. So again, I know you and Josh went at it, but for those who are not, philosophy, who are not math grads or philosophy majors or doctorates, right? I think it's important to, most people think of ontology as an English word. So I want to go back to absolute basics now for a minute. And for them, it's very hard to sort of, operationalize this word in their GenAI chatbot. So when somebody says your chatbot has an ontology problem, it becomes a very difficult statement for them to make sense out of it, right? And I'm sure you meet folks like these. I hope you do meet folks like these who ask you such naive questions. How do you bring them up to speed, especially when there is so much, so much amazing experience that they've had with LLMs, where like the LLM just gets me, man. Come on, right? Like, what's this ontology thing that you're talking about?
Yeah. So, I mean, the pitch depends a lot on who the audience I'm talking to is, like why they're asking me these things, right? If I'm selling consulting services versus whatever. But and also depends a bit, when you say they're coming from LLM stuff and then they're asking me these naive questions about ontology, it depends on whether they're saying, like, this generative AI is doing such cool stuff for us. Why do we also need ontology? That's one side. And other people come to me and they're like, I'm sick of LLMs ruining stuff for me. What can you offer? Right. Then there's a different pitch about what ontologies do. But the first pass, I mean, I might do the left brain, right brain sort of thing here, right? Which is that, yes, we want some gut reactions based on a lot of experiences and a lot of your data. What seems like the likely next thing, right? And so if we're, say, talking about a medical case or something, I looked at 15,000 patients who have similar biomarkers as you, and 10,000 of them ended up having a hip replacement in their mid 60s, right? That's useful information. That tells me like, oh, I should like pay attention to the health of my hip and like maybe what supplements should I take or something like that, right? That's a, machine learning-y, LM-y kind of thing. But I should also be coupling that with things that we understand about the way that the world works, like know what human anatomy looks like, right? We have textbooks, we have understanding about how the joints work, what sorts of things promote joint health, what sorts of genetics encode for likelihoods of hip replacement. Now here's where I just don't know that much about the medical of hip replacements, which is why, of course, you should not pick that example on a podcast, but I ran with it. So here we are, right? So what I think the ontology does is it lays out here's what we understand the world to be like. Here are some like facts and laws about the way that the world works. And that can work in conjunction with this statistical knowledge. Right. So to use an example, I guess we can go all the way back to Cycorp because these I'm not going to be violating any client information at this point. Right. But if we have, if we're predicting stock market stuff, right, we can run like rules and machine learning algorithms to say like these stocks are good good bets or something, or like they're outliers in various sorts of ways, and that can winnow down crazy amounts of data, and then we can end up with a more fundamental few of them, and then we can say, all right, here are 10 ways that we have modeled about how stocks can be overvalued. Here's 10 ways that we have modeled about how stocks can be undervalued. That's part of like our core worldview and model. And then we can test on those particular things. And so it's like use the LLMs and use the machine learning stuff to winnow stuff down, and then be more precise and reasons and sort of rule based on the kinds of things where we're really making decisions or checking things out. Yeah, that's probably a first pass. Another way to go though, all people who are used to LLMs now understand that prompt engineering and like providing context can give you vastly different answers and vastly better answers. And a little bit of what's going on there is you're just trying to ground the LLM on certain things. You're like, take for granted that X, Y, and Z are true, and I'm interested in seeing whether A is also going to be true, and go read this, scientific paper, and now give me feedback on the draft of the paper that I sent you. And that hopes to like get things focused in the right sorts of areas. But you can view that as largely what an ontology is doing as well, right? The ontology is saying, here's a bunch of stuff that we say are true. Here's how these pieces are related to each other, right? And you can feed parts of that graph into the LLM and get better results there. And even if that's not your ending architecture, that gives you an idea about how there's this interplay between the two different types of systems.
Got it. Okay. So that's a good answer. So I have understood the idea and relevance of an ontology, right? Well, yeah. So now going back to what we're discussing just before the show started, which is clients getting pitched ontology, semantic layer, context graph, fill in the words, left, right, and center on consulting decks. And then they get tossed from one team to another team. Because when they ask the actual question, which is, how do you actually build one? Right? Which is the most difficult part of an actual engagement. Right?
Yeah.
And obviously, like there are domains where ontologies have obviously existed for the longest time ever, right? In RDF format and so on. But so two questions, right? One, how do you build one from ground up, right? And second, let's say once you have an ontology, right? How do you operationalize it, right? You obviously gave a very simplified version of that with the example of context engineering and feeding LLM stuff in a better structure and so on. But in an actual enterprise workflow, in an actual agent, let me use the word agent. We haven't used the word agent enough number of times in this podcast.
Yeah.
Sham.
Do
Right?
some SEO,
Sham.
get some more agents in there.
Please,
Yeah.
yes. AO, agent. I think now this will rank better and higher.
Yeah.
So how does my agent actually access ontologically enriched data, if that even means a thing?
Yeah, good. Let's give another like real simple use case for how you might use an ontology, and they'll talk like sort of reverse engineer what parts are there a little bit, and then talk about how you get them, how you build that ontology from the ground up. So a really common method of integration is not even agent centered or anything like that right now that I'm finding. I'm running into more organizations and some consulting firms are hitting me up that say their clients are asking them where they just have a ton of data and they don't even know what all data that they have. And so the problem is we hire new analysts, or our existing analysts just don't know where to find the data that exists at our company. It takes 6 months to figure out where that stuff lives. And then once you do, you get to this database that's got 5,000 columns in it, and you don't even know what all the columns mean and stuff like that, right? So one way to use an ontology is just to say, okay, here are the kinds of things that your organization cares about, right? So let's say that you're an airplane manufacturer or something like that, right? You care about airplanes, you care about all the parts of the airplane. So I can make like a taxonomy, a structure of like all the mechanical parts. And then there's also going to be other things that every company cares about, like HR concerns, so that you have different sub-organizations within your enterprise, and you have employees, and employees have different titles and stuff like that. Okay, so I've got all of this stuff in my ontology well enough that now I can say, now let's get all the databases that we have. And I say, this database is about these kinds of things, and it contains these fields, and these fields tell me about these properties. So now my ontology has a taxonomy of the types of things we care about, like, engines and wings and whatnot. And it also has the sorts of properties that we might want to know, which is like tensile strength or cost or salary, all sorts of things that our organization cares about. So now I store all of that stuff into an ontology, which I'll say more about what that means and how we build that in a second. But then my use case is to write queries against that and say, I want to know what data sets that we have that are about airplane wing tensile strength. And I can go in there and it returns and says, here are the databases, here are where they live, and column XZ is the one that contains the information that you want, right? That sort of thing is incredibly simple, but it's super valuable. All sorts of reasons. One, it just shortens analyst time, right? And two, you figure out, you're like, wait, all right, I find that we have like 7 different columns that are giving us the same information, purportedly. Is that really the same information? Or are we using the same word in different ways? And like, they're not all the same sort of tensile strength. Is one of them just like derivative of another one? And so we can just kill that column and use it? Or, should we express dependencies between our tables? That will help us understand like how data freshness and stuff goes. Now, you can think about how agents would get involved in that and sorts of things. That's fine. But like, I think just at a simple level, making an API call that generates a Sparkle query that's maybe pre-generated and you fill in some blanks. It hits a running triple store and that returns what databases we need. That's an architecture that works for having an ontology and can grow later, right? Because then we know about the sorts of things the company cares about. So then when there's more specific use cases, we already have in the ontology representations about the parts of the plane. So we want to do supply chain information or something like that. I can reuse those parts of the ontology. Okay. So when I talk about the ontology, how is this stuff realized? Typically, there are different like serializations for the ontology, but most of the time I'm dealing with .ttl turtle files, and they're stored in some repository. And you start up a triple store. Maybe that's Amazon Neptune, maybe that's GraphDB, maybe that's Apache Jenna, whatever you like. I just start a triple store, I load those turtle files into it, and that's the thing that I'm running my queries against. And so your question for how do you build those turtle files, right? This is the build the ontology from the ground up. You've got a number of different options. I mean, you said we were talking about this beforehand. The first and most important step is to pay me lots of money, and then we'll solve the rest of the problems, right? But there is some truth to like, you got to find someone who can build these sorts of things, right? They don't just magically appear. In some sense, you might think they magically appear because you could take some third-party ontologies off the shelf, right? So there are these upper ontologies, or maybe you're in an industry, like especially in the biomedical field, there are a bunch of there's a bioportal that has a bunch of different biomedical ontologies in it. Maybe you can leverage some of those. But also, if you're doing that and you don't have any ontology experience, you should be pretty careful because, in the same way that you just can't evaluate whether the stuff's any good or not, right? You want to take this thing and leverage it. I'm not a programmer. I have very limited programming skills, in the same way that it would be stupid for me to think that I'm just going to build my own application by just vibe coding and end up with something that works great. We all know that's nonsense. I'm going to end up with a rat's nest. Maybe it's useful enough to get me going and get some ideas, but eventually, if I want to build a production worthy bit of code, I need to have someone who can oversee it and make sure that it satisfies the kind of constraints that we want for production worthy code. You need the same thing for building an ontology. But how do you build that turtle file? You get someone who's qualified, or you pull in some third-party things. But the nuts and bolts of it is kind of the story that I told at the beginning for the airline company or whatever. You build taxonomies. You build the classes. You say, here are the kinds of things that we care about. Make sure I have a representation for all of them. You say, here are the relationships that those things can have. So you build representations for those. And this has to fit in a special OWL RDF syntax, but that's not crazy complicated. And then you have your data that lives somewhere, and you have to figure out, how can I get my data into that format, right? So you have to build some sort of ETL process. Now, this is why I sort of suggested the metadata strategy, because if you're doing metadata, the way to get your data in the format, I don't actually need to transform my individual rows within my databases, right? The metadata is just, I need to say that this database has this name, it lives in this place, it's about these types of information, right? So then I'm not on the hook for migrating all of my data into a graph. I just need to put my metadata in the graph and I can get some value out of it. But
Got it.
There, that was a lot of stuff. But does that kind of speak to what you were looking for?
It does. It
So,
does.
I had a question. So one is, we need ontologists, we need people like you to consult. But who in the organization would own that asset finally?
That's a great question. And I don't think there's a single answer to that question. And the reason I almost felt guilty about this for a while. I was like, I don't know what part of the company I belong to. And I've been at, several different organizations. I've lived in like different houses within there. The reason that makes sense, I think, is that an ontology is part of the knowledge layer or the semantic layer, or whatever you like, right? And the grand vision is usually that the ontology can store all of the information that our company has, like all of our data can be oriented within that. And so that doesn't live in any single place, right? If we are going to put our HR data in there and we're going to put our stuff, but here are a couple of places that you can be. I think it has a different flavor for it, right? So if the idea is that we want to build better like data schemas that are sort of more future proofed and not like overset to particular applications, then I probably live with the data engineers, something like that. If we're thinking more that, you know what, we've got this LLM that's answering questions for our clients and we want to make it more user friendly so that it speaks the same language and we want to ground it in the kind of knowledge that our clients are going to have, then maybe I'm more on the product side of things, right? I'm more customer facing. I'm thinking about what are the sorts of terms that customers are searching? How can I make those labels and those sorts of things a core part of the ontology so that that's going to surface and make itself, manifest in how clients are interacting with it? Maybe the first use case that you have is an HR one or a accounting financial one, in which case that's the kind of the part of the house that deals with it. But however you slice it, an ontologist is going to want to interact with the engineers who are building the architecture that's going to be housing the ontology. Maybe that's a simple thing where it's just sort of running locally in Apache Jenna instance or something, and I could do it by myself. But most of the time, you want to have some engineers that they're interfacing with, and you want to have some of the product people that they're interfacing with so that they know how is the model that I'm building going to make, a end difference to the user or consumer of this data. But I would say I'm more often than not around programmers and engineers and probably have a slightly closer relation with product managers than some of the engineers do if I had to pick like the modal case.
But
There is a lot there's so many questions now. Casey. Now, I get why this could be sold to a large enterprise or to a larger company where there is a long-term impact visible. There is a story, substance, impact, business ROI, investment outline. There's some champion, some buyer, somebody who actually believes in this, and they can carve out bandwidth for this as a project for like a few quarters and so on and so forth, right? And maybe they have some sort of a knowledge function, a knowledge management function, like a formal function and so on. Right? But most small businesses, most mid-sized businesses, for that matter, don't have these functions at all, right? Their response to knowledge management is exactly how a Gen Z responds to knowledge management. It's part cringe and part like, how boomer are you, right? But then what we're also saying is you need a system too. You badly need a system too to actually make your agents functional and valuable and reliable and so on and so forth, right? It just sounds like a very painful transition for these kind of companies who don't really have a official custodian of knowledge per se, even if it's one function to start with, right? Have you had experiences sort of working with such companies? What does that journey look like for them? How painful is it? Like, what have you seen so far?
Yeah. So for those of you out there listening, the journey with me is very smooth and wonderful. Just so you know, no, it varies. There's a trap that you can get into if you think semantic layer is huge and wonderful and big and holds all of our company's information. And we need to get there so that we can do all the smartest things in the future. ASI will be able to leverage our data and, make us grow 10x or 100x or whatever. You can't do that. You have to but it's like any program or initiative that you want to do. You have to say, what is a problem that I have right now that I can solve incrementally and show value, and then be able to reuse as much of that infrastructure as I build as possible over time, so that it's not it's a single cost that has recurring benefits, rather than I'm going to have to be rebuilding stuff over and over again. That you have to be in some position where that matters. Now, a lot of smaller organizations that I've talked to, where they're like, oh, ontologies sound super cool. Here's the use that I have, and it turns out that their use is they have data that always looks exactly the same and they want to do the same thing with it every time and they don't have any reason to think that's going to change. Like, don't build an ontology for that. Like, what, I don't see what that's getting for you, right? You build a program that pulls that data and parses it in the same way every time and it does everything that you want it to do. So that's fine. But I've worked with, I had a small mid-sized client that was selling or like renting equipment, and they wanted to both like power the retail hierarchy, right? Think, like any commercial, you open your hamburger menus and you find the sorts of thing that you want to rent or deal with. But then they also wanted to provide like smart suggestions to people. And so it was, let's build a taxonomy of products that we have, but then let's also say what those products are capable of. So if somebody comes in and says, oh, I'm trying to repair a blacktop parking lot, and I also need to like get rid of a certain amount of waste, and I need to lift people up to like repair some of the streetlights there or something, right? You can say, okay, which machines have the functionality of lifting people up, that sort of thing. And that was a relatively small process. You can put together just enough model that says the sorts of expresses the kinds of things that you want to say. I think the value that you get is, it's like anything. Like if you're doing your own electrical work, you can probably do your own electrical work in the garage to like wire up a single light or something like that. But if you're going to come back and reuse that later and you want to splice off of it, then you're more likely to get fire hazards and you're more likely to realize I should have put a different junction box at that spot, right? The thing you get from having a professional electrician is someone who's like, okay, you're doing this. That's fine. We can solve that in this way. But if you're going there, let's do this and this because it's low effort now and it's going to give you a lot more options in the future if you ever want to do that sort of stuff. Like, that's kind of what you get from having ontologists help you build out some of these models, right? When you talk about what's a like least painful way to do things, sometimes if you want to play around with how ontologies could help you, you can ask an LLM, build me an ontology for this data set that I feed in, and then practice like, okay, how is that kind of stuff going to work? And that can give you a sense for how you might leverage the ontology, and be a relatively painless way in. And then you just have to decide, like, if this is a long-term project that I'm going to do a lot of stuff, maybe I should invest a little bit more now into saying like, okay, what are the corners I might get backed into here? But yeah, I don't, it sounds more complicated than it is sometimes. I think my recent kick here has been like, an ontology is a summary or a list of the stuff that your business cares about and how those things relate to each other. And you can have an ontology by writing it on a Post-it note and sticking it to your laptop screen. And that's like a first pass of like, okay, you know what? This is what I care about. And that has some benefits already. Like, there's a little bit of ontology that is just like data psychology and data therapy, where you sit down, you're like, what does my data look like? What am I actually using? What do these things mean? Am I using the same term everywhere, or am I using different terms to mean the same thing? Right? Asking those questions can be valuable to you, even if you don't do a single other thing with the ontology, right? So there's a little bit, this is where maybe, philosophers, like, you got the Socratic, the unexamined life is not worth living kind of thing, right? Like, uninterrogated data is pointless. So you use an ontology to like make sure that your data model fits together in the right way and you know what sort of stuff is there. And that's not crazy hard. Now, if you want to put everything into OWL RDF and you want to leverage like OWL reasoners to generate conclusions about named individuals and stuff like that, sure, that gets more complicated, but you want to have a path that gets use out of the ontology long before you get to that point. And so when you're getting value on it there, then you continue to grow it over time.
Got it. Okay. I have more questions now. I have more confusion now. Thanks for this.
All right.
And I know we're sort of also on time right now, but I'll take this one last one, which is because you did speak about there are domain ontologies already available, which people can tap into, can start with, and so on. How should those who don't have ontologists on their payroll, who are not your clients, yet how should they think about transitioning from using domain ontology, right? To say, okay, now I want to, for lack of a better word, fine tune this a bit more and add my own or create something proprietary of my own as well, right? What does that transition look like for somebody, or what does that, that decision itself, right? how would one sort of think about some of those things? Because I agree to your point. Program manage the hell out of this. Start small, scope it properly. Think of it as an infra. Build one, use many ways, and keep on adding to it. Absolutely makes sense, right? Low investments. Track
Good design.
ROI, all of that stuff. Yes, good design, right? But transitioning, or like, I was using Snowmate CT until now, which was good. But like, now you're asking me to build my own. Like, how does that integrate into it? Are there clashes? If there are clashes, who will resolve it? If I call, Casey, but Snowmate calls Casey Kaisi, like how? What happens then? Like more questions, basically. Yeah.
Yeah. So the first thing to say is I take some, ontology off the shelf or whatever, and I want to change it. My metaphor for that is like you're buying a house, right? And often you're like, I'm going to knock down that wall later, or I'm going to add an extra bathroom or something like that, right? And some projects are more destructive and harder to do. Like repainting some walls, not so bad, right? If I just want to add some labels to the ontology and be like, great, I like the structure of this one a lot. It's just we call it something different here at in the AmeriCorps, but great. Then you just add a label. Or maybe I just want to say, okay, that has a category for diseases, but it doesn't have a category for like, bone breaks or something like that. So I need to create a new class that, sits alongside a sibling class and then provide definitions. And those aren't hard, right? You take the turtle files or whatever you had the ontology stored in. Maybe you just expand the existing file. Maybe you create a new file that just has your triples in addition to the other one, however you want to store them. Not super difficult. The difficult changes, right, are if you want to totally refactor parts of that ontology, especially if, okay, we've been working with this for a while, right? And we have APIs that are calling and writing queries against the graph. And now we want to change key parts of the vocabulary of the graph. How is that stuff going to work? And that's hard, but that's not any different than any other, software development stuff that you're doing, right? Like if you're changing your payroll software, or when I worked at Amazon for a bit, right? Like if we're changing the what the landing page looks like or something like that, then that's going to break a lot of stuff. And how do you handle that? You make regression tests. You have staging development stuff, other just like good development practice. I would say that rolling your own ontology or thinking about an ontology, you just want to say true stuff in your ontology, right? So if your goal from the start is, I want this model to say as many true things as we believe as an organization. I know I'm not going to get it perfect. I'm going to have some false stuff, like, because in part, even if I perfectly capture what we think right now, certainly we have some false beliefs about the world right now. We're going to have to revise those later, right? So you have to go in knowing that some of the stuff is going to change and that you're going to add and enrich it. And lots of the time, the best thing to do is say something that's true in general and know that eventually we'll be able to say more fine grains and specific things later, right? So I'm going to create a class for employee, done. Now I'm going to maybe need to put exempt employees and stuff like that in later. And that will be a subclass of that and I can handle it, but I just need to know, okay, I've got a place where that's going to go. So I know that I'm not blocking myself off from doing that. And then I'll handle it when it becomes a valuable and useful thing to do. I
Yeah.
don't know how
Okay.
much that
Yeah.
speaks to
No,
the
it does.
issue, but yeah.
It does. It does. It does. It helps a lot. I think the example you gave was beautiful. That depends on like what you want to do and how much you want to do, and the fact that it's like just any other software migration, upgrade, updates, sort of a process. Just
Yeah.
think through it. Yeah.
One thing that's really important here, and it's a thing that like I feels so natural to me, but is clearly not to a lot of others in the software world, and for good reason, given the other structures. But there's the open world versus the closed world assumption, right? So the closed world assumption says if it's not true in our data model or our schema, like if we can't prove it to be true, then it's false, right? Like we assume that our data model fully encompasses all the things that exist from our company's perspective, right? And the open world model says if it's not true, like not provably true in my model, maybe I just don't know about it, right? And that's the way the OWL RDF thinking goes. Like I put a bunch of slots in the ontology. I don't think I've fully represented everything in the world, right? Like I say there's employee. That doesn't mean that there's not more specific kinds, right? I asserted that Casey's an employee and I didn't give his social security number. Does that mean he doesn't have a social security number? Of course not. It just means that I don't have it in my data set, right? And I think people who are used to closed world assumption, like schema building and models, they get like, oh no, I've got to get it all in there, right? When I first build this model. And that's not all the way to think about OWL ontology building. You're building as much of the model as you need to answer the questions that you need to. And as you get better at that, maybe you're going to get good at like guessing ahead and maybe putting a little more detail in places that are going to be useful later, right? But for now, you just say all true things, as many true things as you can that let you use the model for the purposes that you have, and that will continue to grow and expand over time.
I think programmers can get, I guess the analogy would be like, how would you design, let's say, a table? And based on the assumptions in that design, you would say that for whatever reason, you're not going to get a social security number, but maybe another opposite assumption in a different system would have said we must get this social security number, without which we're not going to create the record. So it's I think down to design. If you put it in those terms, I think uh, programmers can get that it's basically a choice. There could be an open world, that you don't know what you're missing.
Yeah.
Everything is not sorry. Everything is nullable.
Yeah, there you go. From on the other side too, right? I don't want to give the wrong impression here. There are lots of times when I want to close my world. There are times when I want to say, if I don't have a social security number for my employee, throw an error, right? Like that's bad. This is my HR data. I expect to have that stuff, and it's a bad sign if it's not there. And there are different ways you can enforce that. There are things like Shackle that specifically look at that validation, or you can just build your own infrastructure around it that writes Sparkle queries against your database, looks for things that are missing that you expect to be there, and then throws errors. So all that stuff is good. But it's a live question whether you want any piece of data to be viewed as exhaustive or not.
Perfect. No, thanks. This has been very, very interesting. I know for a fact a lot of people, in fact, a lot of software folks who have conventionally distributed software would want to, prompt their LLM. What does the ontology look like if you had to create it?
Yeah. And there I will just, reiterate I think that's a great thing to do. Do it and see what kind of stuff turns out, but don't fall prey to if you asked it to write your program for you, right? That it would do some good stuff and it would do some really stupid stuff, right? So don't just assume, since the output is like, oh, that compiles and that's Turtle, like, yeah, it can make Python that compiles too. That doesn't mean that it's all good. So run with it in the responsible ways of using generative AI, and not in the great, looks like we don't need ontologists after all.
I like the responsible ways of using generative
You gotta
AI.
post that out here on the top sponsor.
Responsible ways. I think it should be my backdrop, right? Responsible use of AI, not responsible AI, but responsible use of it.
Yeah.
That's a good
We
one,
have.
obviously.
I've seen this on a number of emails now where there's like, this content was partially produced by, AI. It's like, please check and use at your own discretion or whatever. It's like the Surgeon General's warning on a box of cigarettes now.
All right, Casey, thank you so much for this. This is absolutely fantastic, right? But before we go, I know you have an amazing YouTube channel where you bring in a lot of experts and a lot of academic, folks from academia, and you go at it, right? Where should your future clients and how should your future clients contact you?
Awesome. Well, thank you. Yeah. So I do a few things. I have my YouTube channel, which is Ontology Explained. And I just started a new podcast with a guy, Carl, from the Internet of Bugs, called Philosophy Programs and Prompts. You can find both of those if you go to caseyhart.com. There's links there, and you can find what you want about me. You can hit me up on LinkedIn, number of ways. If you look a little bit, you'll find your way to me. So yeah, feel free to reach out. I always enjoy having conversations about ontology stuff.
Awesome, Casey. Thank you so much once again. Appreciate you having you here.
Thanks, Casey.
Fun to be here. Thanks, guys.
When a model invents a fact, we call it a hallucination. And that somehow makes it sound smarter than it actually is. This is what I love about Casey's phrasing. His model is sharper than the usual complaints. The model was not malfunctioning. It was doing exactly what it was supposed to do, generate. It did. Problem is when we ask a text generator for the truth, and then surprise. This is exactly also why Casey will not take the answer without the why. Ontology is exactly how you get the why. not some mystical enterprise mega project. Honest, written down list of what your business cares about and how those things actually relate to each other. You can start with it on a post-it. You can start with just a metadata. Mostly have all of those things already ready with you. If you want more of Kason, he runs the Ontology Explained channel on YouTube, and he has a brand new podcast with Carl from Internet of Bugs called Philosophy, Programs, and Prompts. I love that title. Everything is at kchart.com. Link is in the show notes. One thing before we go, if this show is useful to you, do rate it wherever you are listening, Spotify, Apple Podcasts. This is the entire marketing budget for us. Once again, this is Context Ops. If you are building enterprise AI in production, this is the show for you. And remember where we landed at the end. Responsible use of AI and not responsible AI. Once again, thank you for listening.